Up next, we'll be talking about safety. This is something that I think is a big concern to a lot of people. Hydrogen, you can't see it, you can't smell it, so you need to detect it somehow. Thomas Schwenk here from MSA Safety will be talking about the safety of hydrogen fueling, innovative detection technologies. Please, have the stage.
Good morning, everyone. Can you hear me? I want to talk to you about hydrogen fueling, about gas and flame detection for this application. Second one. Short agenda. Fuels review, hydrogen fueling, safety checkpoints, and the conclusions. So, why hydrogen? 100% sustainable. Green energy does not emit polluting gases either during combustion or during production. So, storable. Hydrogen is easy to store, can be used subsequently for other purposes and also at other times. Versatile. Green hydrogen can be transformed into electricity or synthetic gases and used for commercial, industrial, or mobility purposes. So, hydrogen compared with common fuels. There's hydrogen, propane, gasoline, and gasoline vapor, and methane. So, by the way, gasoline is liquid usually, but dangerous is a mix between vapor and air. That's the most dangerous combination for gasoline vapor. Explosive level range. This is a range between LEL, the low explosion limit, and UEL, that's the upper explosion limit. This range is most dangerous because the gas can explode. The explodes range from methane is from 4.4 volume percent to 16.5 volume percent. That is small. But for hydrogen is a range 4 volume percent to 77 volume percent. Please note 77 is a very big range. So this is a high risk potential, definitely. The second comparison is ignition energy. For hydrogen is ignition energy 0.02 millijoules, and for methane 0.29 millijoules. This ignition energy for hydrogen is less a power of 10 against methane, very small. It's a risk potential too. Next comparison. So hydrogen compared with common fuels, gasoline and LNG in regarding to leak rate. And the leak rate for hydrogen is significantly higher against gasoline and LNG because of the gaseous status and the structure of the molecules from hydrogen. So decarbonization of transport can happen with H2. In my opinion, for trucks, is this the best solution, for cars partially. And with many fueling stations planned with public areas to address the public safety concerns by complying with the ISO 19880-1 requirements for gas and flame detection. ISO is the International Organization for Standardization. And the ISO standard 90,880-1 is a standard for gaseous hydrogen fueling station. From now, the ISO standard, too many figures. So, and gas and flame detection for hydrogen fueling station are mentioned and required for protection of people and equipment in the ISO standard. Purpose is to avoid flammable mixtures of gas and air and the escalation in the case of a fire. So, hydrogen gas and flame detection is detailed described in these parts, as you can see, of the ISO standard. This is implemented in an example for the complete monitoring of a fueling station. Base is a risk assessment from the operator in combination with the ISO standard. So you can see here 10 measuring points gas detection are installed outside. These are the green points. The 2 measuring points outside near to the dispensers and 8 measuring points inside in rooms or containers for monitoring of electrolyzers, analyzers, instruments, etc. So additional is installed outside 1 measuring point ultrasonic gas leak detection. That's the blue point. This detector monitored the pipes and the equipment outside. The 5 flame detectors are installed outside for monitors of the dispensers and the complete hazardous area. These are the red point. And the safety of the fuel injection is guaranteed because of the covering of the ISO standard and the complete solution with gas, leak, and fire detection. Hearing, smelling, seeing. By the way, in gas detection, safety with 100% is not possible, never. But this concept, this solution is very safe. So, yeah, the devices. Gas detection. Gas detection will implement it with catalytic gas detectors for the measuring range 0 to 100% LAL, and with EC cells or electrochemical cells for the detection in the ppm range. For example, 0 to 1000 ppms. ppms part per millions. Standard is 0 to 100% LAL. Hydrogen has a LAL from 5 volume percent. For comparison, 1 volume percent corresponds to 10,000 ppms, parts per million. This is a complete different level. Now, the catalytic sensor has a big mechanical performance and a long life cycle because of the size of the filaments. The platform X5000, as you can see, has a possibility for dual sensing and can cover both measuring points with 2 sensors on 1 measuring point. The sensor safe swap for replacement of the sensor in the field without shutdown is a very useful benefit in it. So, oopsie. Flame detection. Flame detection will implement it with a flame detector UVIR. This detector combines an ultraviolet wavelength and an infrared wavelength. The standard version is usable for hydrocarbon fire. So, for hydrogen fire is a special version development. The flame detector is safe because of a built-in check. That means the system generates every 50 minutes a self-check. Testing for service is very quick and easy because of a test lamp, only with pressing of a button. So, third measuring principle, UGLD. This is ultrasonic gas leak detection. It's a horrible word, I know. The ultrasonic detector doesn't need physical contact with the gas because it detects ultrasound. In case of a leak in high-pressure installation, the gas flow generates an ultrasonic noise. You can hear it too. It is a hissing sound. A hissing sound additional. And the ultrasonic detector can hear the noise, the ultrasound noise, without delay. So, and it can cover a 360 degrees area. So this measuring principle is independent from weather condition. Rain, snow, fog, additional. And as said, it can hear. So the flame detector can see, and the gas detector can smell. Smelling, seeing, hearing. And these 3 fixed gas and flame detection techniques are very effective for hydrogen gas detected and fire response, indicated by the ISO standard. So they are additional very effective for prevention in the combination together and in regarding to the application. So the quick response to H2 leaks and H2 fires with diversified technologies will improve the safety of fueling application in general. If you are interested, we are on the booth F37, and you can see the devices in the real life, if you want. Questions?
Thank you, Thomas.
Okay.
Please give Thomas a round of applause. So, are there any questions from the audience, or any of you concerned with safety? I see a gentleman over here. I'll bring the mic to you. Please.
Can you give some information on the range, the distance of detection of your detectors?
The ultrasonic detector has a range for the standard sensitivity of 70 meters and for the highest sensitivity of 29-30 meters. The flame detector has a range approximately 50 meters, and the gas detector depends on the application, but we say one gas detector can cover an area of 25 square meters, approximately.
All right. Any other questions from the audience? Maybe I have one more question. So, if you were to compare hydrogen vehicles to other vehicles, what do you think are the safer options?
What do you mean? Sir?
So if we compare a hydrogen vehicle, a fuel cell vehicle, to, let's say, a gasoline or a battery-powered vehicle, what do you think are the safety concerns?
Safety concern, how can I say? For example, gasoline, it's also dangerous. No? Gasoline can burn, and we know every case that burn a car. Hydrogen has a big risk potential, as explained, but we can cover the safety.
Exactly. I think that's a nice conclusion to end on. Everything that has a lot of energy in it is dangerous by nature, but if we handle it correctly, we can make it safe.
Battery power is also dangerous, no?
Exactly. All right, let's give a round of applause for Mr. Thomas.
Thanks a lot.